Hello everyone, today we are going to create Wind similar to the Wind in Celeste using Pygame and Python. Let's start with our project. In order to get started, we need to install Pygame-ce, which is a version of Pygame that has all of the features of regular Pygame, has some tweak improvements and also some extra features. To install it, we need to open the terminal and then type pip uninstall Pygame and then hit enter. And then after that hit pip install pygame-ce. Put a dash between the pygame and c, and then it will install the pygame-ce package. If it also wants you to install some dependencies, type y and press enter. You might also need to prefix this command with python-m or python3-m. So now that we've got this out of the way, let's move on to the actual project in it. Now that we've installed pygame-ce, let's go over to here and create our main.py file. In here, I'm first going to import pygame. I'm just going to import it normally. I don't need to put this in here. It will just import normally. And after that, I'm going to define a constant that will be our screen size. And for this, I'm going to put 800 by 450. After that, I'm going to create my application class called app. Let's create our init method here. So it's going to be self, and it's going to return a none. We'll say self.screen equals pygame.display.set mode, which is screen size. After that, we are going to create a clock object called self.clock, pygame.clock. We are going to also create self.isRunning, which is going to be false. Also self.deltaTime, which is going to be 0, and self.events equals an empty list. This is going to be our input events. So now let's create the main run file. Self.isRunning equals true, and while self.isRunning, we are going to say self.handle events, self.update, and self.drop. And also we are going to call pygame.display.update. This will basically refresh the screen. And we are also going to say self.deltaTime equals self.clock.tick, and we will put 6 in here, which is the frame rate. We want to limit the frame rate at 60 FPS. Updates, we are going to not read anything in here as of currently. We are not going to put anything in here. And in our draw class, in our draw function, we are going to put self.screen.fill black. We are going to fill it with black, and that's pretty much it. I'm also going to put this in here. If __ name equals main. So this means that if I'm running the file as a main file, if this is the root file, then it's going to create an application class, and then it's going to run it. So now let's just test it out. And oh yeah, we forgot to add the function in here. Def handle events self.events equals pygame.events.get. And for event in self.events, we are going to say if event.type equals pygame.quit. So if you want to quit the app, we will say self.isRunning equals false. And so now it should work. Yeah, we have a window that we can just move over and close. So yeah, we've created the basic initial project setup. Now that we've got the basic project set up, I'm going to create a particle class, and I'm going to just make the thing, just make the application draw the particles. So let's start by defining another constant called particle count, and let's just give it 100. I'm also going to import two new modules, import random and import typing. You do not need to give typings in Python, but I like to give them. They make complicated projects easier to deal with. And so after that, let's create our particle class called class particle. Let's give it an definite. And also, while creating this, we are going to give it position and also radius. So let's just pass it this. So the position will be this, and the radius will be an integer. And this will be typing.list, which is an integer. I'm using list instead of tuples because tuples are not mutable, so you can't change them after you declare them, but you can change list. So I'm going to use this in this project. Let's also create another class called particle manager. It will also get the particles. It will just be an empty list at the start, and let's give it type hints as well. Let's also give it an update method. It won't do anything right now. Let's also add another function for adding particles. Underscore in range particle count, particle equals particle, and so now we have to give it position. And for position, let's use a list random.randint, and it's going to be between 0 and screen width size. And for the Y position, we are going to do the same, but it's going to be height this time. And after that, we are going to also give it a radius, and that's going to be between 3 and 6. Yeah. And also after creating the particle, we are just going to add it to the list. Let's also create the draw method. Oh wait, no. Yeah, I forgot to give particle a draw method. It's going to be screen, and then the color, and then the center and the radius. Particle.draw screen, and that should be it. And now in our class instance, we are going to create our particle manager. And before we start running the project, we are going to say staff.particleManager.add particles, and here in our update means we are just going to call staff.particleManager.update, and in here we are going to say staff.particleManager.draw, and it's going to give its own screen. So now let's just test it to see if it's working. And yeah, we have particles that we can render. Now that we've created the particle class, let's just make the particles move. So firstly, I'm going to go into particle class and create a new method for it called update. This method is also going to take delta time as an input because I want the particles to move regardless of the frame rate of the end user. So we are just going to multiply the amount of delta time that passed since the last frame by the speed of the particle, and we are also going to add speed as an attribute in here. So let's just put speed in here. And in our particle update method, let's just say we first want to make the particle go left, so we'll say self.position 0 negative equals self.speed multiplied by delta time. And also we're going to say if self.position 0, which is the x position, is smaller than negative 100, then we will say self.position 0 is going to be screen size 0 plus 100. The reason that we are doing this is because if we were to just make the particle disappear at 0, then it will just disappear like instantly, because some particles have a radius that's bigger than 3 and smaller than 7. So it's in the range of that, and so it will just make it look like as if they just instantly disappear once they're out of the screen, which is something that we don't want. So we're just going to add the 100 or negative 100 as an offset. So now that we've done this, let's go on to the particle manager update method, and in here we're going to say for particle in self.particles, we'll say particle.update. We are going to give it delta time, and in our application class we're going to say self.particle.measure.update, and we're going to give it self.delta time. And also we're going to give speed in here. Let's give the speed between 4 and 8. Oh, and also I forgot to give type hints for speed. Yeah. Hold on, wait. We should actually move this into here. Yeah. Yeah, okay. So now that we've done this, let's move on. And I think that there's nothing left. So let's just check if it's working. So yeah, as you can see, they're just moving really, really fast. So to get around this, we are going to come into here, and we are going to divide that by an arbitrary amount. I'm going to divide it by 18. It gives real cool results for me. So let's just, yeah. So now our particles are like moving, and currently it looks like it's in space, but once we are done with it, it's going to look better. So yeah, we've done this. Now that we've implemented particles moving horizontally, we are now going to make the repeating wave pattern. So first, to start off, we are going to give some more attributes to the particle class. We are going to give them a time offset and we are going to give it the time offset, and we are also going to give them a wave speed. This will make sense in a right around. Basically, time offset, we are going to use the current time as the input for our math.sin function, and also for wave speed, we are going to multiply the value that we get from math.sin by this wave speed value, and yeah, that is basically how it works. So let's just take them as inputs, and actually, since this function in its inputs are like that much long, so let's just write them like this so it's easier to understand. So we're going to say time offset, which, if I recall correctly, was a float, and also wave speed, which is an integer. Am I correct? No, wait, no. this is supposed to be an integer, and this is supposed to be a float. Okay, we've done this. And in our update method, let's just come to here. So yeah. Oh, by the way, I forgot to mention, in Pygame, negative horizontal coordinates, negative x coordinates mean left, positive x coordinates mean right. But once it's vertical, so it's y position, it's actually the reverse of that. So in Pygame, positive y values mean down and negative y values mean up. So yeah, in here we're also going to say if self.position 1 is smaller than negative 100, so it's up up of the screen, so it's the top of the screen, or if it's the bottom of the screen, which is self.position 1 and is bigger than screen size 1. So if it's top of the screen or bottom of the screen, I forgot to add plus 100 in here, then we will say self.position 1 equals random 100 and screen size 1 negative 100. So yeah, if it's just going to check if the particle is also 2 up or 2 down. And after that, we are also going to say in here self.position1 plus equals math.sign, and also we need to first import math as well. So let's just say import math. So it's going to take math.sin, and math.sin is going to take time plus self.time offset multiplied by yeah, no, not in here. The update method is going to get the current time, and we are also going to multiply this by wave speed as well as the delta time. So we've got this, and in here we are going to come to here. We are going to give it time as well. So let's also get time in input as an argument. And while also spawning particles, we are going to give them a time offset, which is going to be random.randint, and it's going to be -4 and 3, and the wave speed is going to be 1 plus random.randint -15 divided by 10. So let's just put this in here, and after that, I don't think that we, oh yeah, I forgot also to put another thing in here. We're getting this after delta time, but we're also going to initialize the time as well, and it's going to get this, and also it's going to increase the time by self.delta time divided by 100. And also, I also want to just add an example image from Celeste. So let's just say self.background equals pygame.image.load. The name of the image is background.png. You can download the files of this project from the GitHub. I will leave a link to the GitHub repository. And I'm also going to call .convert. Basically, convert just optimize your image. If it has transparency, you can also use convert alpha, but mine doesn't have that, so I'm just going to call it convert. And also, I'm going to say self.background equals pygame.transform.scale, and so it's going to scale the image to a given size. I want to scale the background to the screen size. So yeah, we've done this, and after that we are going to say, if I recall correctly, yeah, we are going to call this, we are going to give it self.time, and also in here we are going to say self.screen.split, self.background, and we are just going to give it 0, 0. So now if we test this, we should hopefully get the desired outcome. Wait, wave speed is not defined. So let's just come in here. Yeah, I forgot to put self.wave speed. So now it should work. Well, why isn't it working? Okay, so now we've found the problem. Let's try to fix it. Oh yeah, because we are drawing the particles, but then after that we are just drawing the background. This should instead be the reverse. So we will first fill it with black, and then we will draw the background, and then we will draw the particles. And so yeah, as you can see, we've got a really cool Celeste-like wind particles. Also, I want to do something real quick. I want to come into here and change this so it's -100 and -100 and +100 and +100. Yeah. So now if you so now the particles just be evenly spaced out, and yeah, it just looks really good, really good. I hope you enjoyed the tutorial, and I would appreciate it if you could just leave a like and subscribe. See you next time. The tutorial repository will be in the description. Bye.